Okay, so a little bit about piecewise functions. First, we're going to use one to evaluate some function values. So if I want like f of 2 here, remember that means I'm looking for what I get out when I plug the x value of 2 in. So I have to decide what piece to use. My x equals 2 does not make my first inequality true because 2 is not less than or equal to 1, so I'm not going to use that piece. But 2 is greater than 1, so I'll use my second piece, which just gives me out -2, no matter what x value I'm plugging in. For f of 0, again, look at your inequalities and decide which of them is true for that x value. If x equals 0, 0 is less than or equal to 1. It is not greater than or equal to 1, so I'll use my top piece. Plug that in for x, gives you 1. So the inequalities tell you which piece to use. All right, let's do some graphing. So this is like multiple lines on the same graph. We just want different sections of them. For 2x minus 4, let's just graph it like we would normally. Start with my y-intercept of -4, up to right 1. And then where it becomes piecewise is I'm only supposed to be graphing it for points that have x values less than -1. So if you think about x values less than -1, that green kind of dashed line splits off x values that are less than -1 on the left side and greater than -1 on the right, if you think about your x-axis or look at your x-axis. So I only want the ones with x values less than -1, so I'm going to erase everything extra. And it's strictly a less than, so my one at -1 is going to be an open circle. Let's do our second piece. So -2x plus 2, y-intercept of 2, slope of -2. And this one, you are only supposed to have points that include x values greater than or equal to 0. So thinking about the points that have x values greater than or equal to 0, those are the points in that green box right there. Thinking about your x-axis, those are where the values greater than 0 are. And this one is supposed to be including 0, so it's a closed circle on my point at 0, 2. There it is. Domain and range-wise. My domain, you can either look at your function definition or you can look at your graph, but I go from -infinity to -1, then I don't have any points between -1 and 0, and then I start up again and include points from 0 to infinity. For my range, I kind of have a largest y value. I include all of the points with y values up to 2, and then everything else has y values less than 2. So -infinity to 2 is going to be my range. All right, so let's do another one here. So my first piece is just a horizontal line because it has output of 4 for all the x values that are less than 1. So it's got like points 0, 4, -1, 4. So my first piece looks like that, open circle, because it's strictly less than. Then I have an output of 5 if x equals 1. So just for that single x value, I get an output of 5. That's just a point at 1, 5. And then for my third piece, it's 2x minus 1 for x values greater than 1. So if I kind of use my slope and y-intercept here, I'm not going to draw in the whole thing. I'm going to think about, okay, I need the points with x values greater than 1 and not including 1 itself. So open circle and then points to the right of that. We are going to write some equations for a piecewise function. So if you look at this, it has 2 separate pieces. So there's basically going to be 2 parts to my equation for my piecewise function. I'm just going to kind of set it up here. Piece number 1 and piece number 2. So that orange piece, which is the one kind of on the right of my graph, is the horizontal line y equals 2. And it starts at the point where x is 1 and continues to the right where the x values are greater than 1. So that's just going to be 2 if my x values are greater than or equal to 1. My green piece is a horizontal line y equals -3, and it ends at the point where x is equal to 1 and continues to the left where all my x values are less than 1. Be careful with your inequalities if you have an open versus a closed circle. Now this one has 3 separate pieces. So let me kind of lay it out here. It almost looks like it could be done with 2, but you can't use an absolute value function for that one on the right because that piece in orange has a different slope than the piece that I just highlighted in red. So I'm going to use 3 pieces. I'm going to start with my green piece, which is another horizontal line. It's the point with all the y values of 1, where my x values are less than or equal to -1. My orange piece, I'm going to do some slope-intercept form here. So my slope going down 3 right to my slope's -3/2. And then I need to figure out my y-intercept. I could estimate it, but I don't want to estimate it. We need to be exact here. So let's plug in a point that's on my line. I could do -1, -1, and plug those in for x and y, and solve for my y-intercept, which is going to give me -1 minus 1.5, -2.5. So that equation is y equals -3/2 x minus 2.5, and it is for the x values that are greater than -1 and less than +1. And it's an open circle on my -1. On +1, I could choose to use an or equal to or just a less than, but that would influence what I do on my red piece. Either the red piece or the orange piece needs to have an or equal to on x equals 1 because there's not an open circle there. Okay, for the red piece, my slope is going to be +1, thinking rising up 1, going to the right one. And then for my y-intercept, easiest way is just kind of imagine extending that line back. It would intersect the y-axis at -5. So y equals x minus 5 is my equation for that piece. So x minus 5, and it is for the x values greater than 1. Now I'm not going to use an or equal to because I did that on my orange piece and I need it to be a function, so I can't have 2 pieces that share the same x values. We are going to use a graph of this piecewise function that represents the profit made by a company. First, we want to estimate the final profit. So when we stop measuring after 6 months, it looks like they've made $20 million. It's important to look at your scale because is this $20? Is it $20,000? It's $20 million. We want to know when the profit remained constant. It remained constant between months 3 and 4. And then if we're approximating f of 2, after 2 months, it looks like they made $5 million profit, approximately. And if we want to know what the average profit that they made between 4 and 6 months was, well, if you kind of look at your slope, your rate of change here, they made $5 million over 2 months. So that would mean that their rate is $2.5 million per month in that time interval.